see this. Is that okay? So that we just started off with these three problems. We're going to start the next one down here. Okay, so now we have log raised 2 of secant pi over 3. So remember, pi over 3 is the radian, right? So if you don't recall, um, secant is a reciprocal cosine. So you should already know what cosine of pi over 3 is based on the table, which is 1/2. So that means secant is equal to 2 over 1. I think someone's mic is on. Yeah, you can do a. All right, cool. So now I'm going to put 2 over 1 because secant pi over 3 is equal to 2. So this is log base 2 of 2, which is then equal to 1. So easy peasy. All right, number 3. We have sine theta is equal to -7/8. Look at that. We see these problems like all the time. This is on the exam too. Um, we're in 180 to 270 degrees this time, right? So that means we're in the third quadrant. So this is quadrant 3, and if I'm in quadrant 3, I have a triangle that looks like this, right? And theta, so sine is opposite, right, over hypotenuse. So I know this is -7, this is 8. So this is 64 minus 49, square root of that, and it's the negative, right? So I get negative square root of 15, which we can't simplify. Therefore, cosine theta is adjacent over hypotenuse. That's negative radical 15 over 8. Cosecant squared. Notice they're not asking for cosecant. They're asking for cosecant squared. So that one is just the reciprocal of sine and then square it, right? So it's negative 8 over 7 squared, which is what? 64 over 49. And then tan theta is opposite over adjacent. So opposite over adjacent, which is 7 over radical 15. Now, I know many of you are asking, do we have to rationalize it? You can. If you do, it's fine. Just don't mess up. But even if you didn't, as long as the radical in the denominator is simplified radical, they will accept it, unless they tell you to rationalize it in the directions. Just for these problems. But other problems with radicals, you do have to rationalize. Okay, is that clear for everyone? You can't see anything? Oh yeah, so John, I don't know if you saw, but you have to hover over my name. Click on my name and then click the join stream. Or on the live button. Yeah. Did you get in, John? Let me see. 1, 2, 3, 4, 5, 6, 7. I think we're missing. I don't know if Jake got. Oh no, Jake isn't here. Brandon is here. And Danielle. Okay. All right, let's continue on. If you have questions, just feel free to just, you can talk or type it in chat. Okay, now this one is asking for exact max or min, right? Exact max or min. So I don't even have to graph this. This is just telling me what's exact max or min. When I figure out max and min, I look at these two numbers, the amplitude and the vertical shift. So I start off with the vertical shift and I add the amplitude and subtract the amplitude. So that tells me max and min. So 19 and 5. Okay, any questions with that? Right, so this one they're asking for exact max. So for this one I would just put 19. Very simple. Okay, Find a domain of the logarithmic function. I know some people, it's been a while, so if you didn't study enough, you probably forgot how to do this. But if you remember, there's a vertical asymptote, right, for this type of problem, right? For any log x problem, there's a vertical asymptote at x is equal to 0, right? So what do? We set this to find the domain, right? We have to set whatever is inside the log function as greater than 0, and then find cut points. So this is 4 plus x. 4 minus x is equal to 0. So x is equal to -4 and +4. So these are our cut points. And then for the analysis part, I don't know how they're going to ask you in the essay portion, but I would imagine you just type in numbers. They'll have these empty spots for you to type in these different numbers. So here's -4 and +4. And then I'm going to substitute -5, 0, and 5. So if I plug in -5, I get a negative and a positive gives me negative. 0 would give me a positive, and a positive is positive. 5 would give me positive and a negative, which is negative. Okay, so where's my interval notation? It would be from -4 to +4 only. Any questions? We doing all right? Okay. Look at this. Wow. They want us to order this from the lowest to highest value. This is actually, this one was a non-calculator section in the previous final, but obviously you have calculators to work with, so it doesn't seem too bad, right? But how would you do this? You should still know how to do this based on the properties, right? Okay, so I know ln of e to the -4th is equal to just -4, right? And then how do we know what this is? Negative log base 3 of 82. So I don't know what it is, but I can compare it to something I do know. I can compare it to negative log base 3 of 81, right? Which is negative log base of 3 to the 4th, right? Which is equal to -4. So negative log base 3 of 82 is actually less than negative log base 3 of 81, which is equal to -4, right? So this is actually smaller than -4. And then for the last one, this is 1, 2, 3, 4. Negative log of, I guess I'll put 10 to the -4. You see that? So this is negative times -4, which is +4. Okay, does that make sense for everyone? Okay. So now I can see this 3 is the highest one, right? So I'll put 3 here. And then the smallest one is the negative log base 3 of 82. And then ln of e to the -4. All right, any questions? All right. Shall we take a look at this? We have, let me move this over here. Okay, so it says let g of x equal ln of x plus 3 minus 4. Find g inverse of x. So how do we figure this out? We have to swap x and y. So I'm going to put x is equal to ln of y plus 3 minus 4. And solve for y. So that means I have to add 4 to both sides. So I have x plus 4 is equal to ln of y plus 3. Now to clear the ln on both sides, I have to do e to the, right? That way e to the x plus 4 is equal to y plus 3. And lastly, we subtract 3, right? So this is e to the x plus 4 minus 3 is equal to g inverse of x. Right, e to the x plus 4 minus 3. Okay? Any questions with that? For part B, we just simply substitute negative 4 into our inverse function right there. So you could do e to the negative 4 plus 4 minus 3. So that's e to the 0 minus 3, which is 1 minus 3, is equal to negative 2. Okay? Now, there is another way to solve this. I don't know if you know, right? You know how g inverse of negative 4, right, means it's for the original g function, it's equal to y. That's y is equal to negative 4. So if you wanted to, you could have done this. ln of x plus 3 minus 4 is equal to negative 4. And then you do ln of x plus 3. We add 4 to both sides and we get 0. Right? So now since this is base e, you do e to the 0 is equal to x plus 3. And then subtract 3, right? So this is 1 minus 3 equals negative 2. Is that cool? Hey, John, you joined us? Can you hear us? John, your mic is on, so we could definitely hear you typing. Or maybe using push to talk. Yeah, there you go. Okay, cool. Are you able to hear us okay? Or hear me okay at least? Okay, great. All right, let's continue on with this. This is the graph of f of x is equal to log base a of x plus 4. Given below through the coordinate pair 1, 2. So if you look here, 1, 2 is this point right there. Okay, find the value of base a. So how do we know what the base a is? Well, one thing's for sure, we know a couple of other points here. I know there's a negative 2, 1, and possibly a negative 3, 0. But let me just double check here, okay? So I'm going to substitute what we do know into this function. So that means 2 is equal to log base a of 1 plus 4, right? So we just substituted 1 and 2 into the equation. So that gives me log base a of 5, right? So that means a squared is equal to 5. Does that make sense? So I can square root both sides, and we get a is equal to, since a is a positive number, it can't be negative, it's radical 5. That's not too bad, right? All right, moving on. All right, here's another common question here. Complete one period for this trig function here. So one period, right? So I'm going to do, what I do first is factor out the 3. So I get divide out of 3, and I get pi over 18. Right? So this is 5 cosine of 3 times x minus pi over 18 is equal to f of x. All right, so first thing is the amplitude. Amplitude is always the absolute value of the coefficient. So it's just 5. And then for the period, it's always 2 pi divided by this number we factored out, this 3. Right? So 2 pi over 3. Now it says the reason we had to factor is this. X minus pi over 18, right here. That tells us the phase shift. So we're going right pi over 18 units. Okay, so hopefully that's clear for everyone. And to sketch it, I'm going to go right pi over 18. So this is where I start. And I'm going to end at whatever this endpoint is. How do we figure out the endpoint? You take what you started with and you add the period to it, right? So this is times 6, so it's 12 pi over 18 is what we're adding, right? So this is actually 13 pi over 18. 13 pi over 18. So now we cut it into 4 equally spaced intervals. Now how do I know what to add? This is the part, I don't know if you remember, I said you take the period and you multiply by a fourth. So that way you get pi over 6. Right? Pi over 6 is what I keep adding. So my first number was pi over 18 plus pi over 6, which is 3 pi over 18. So this comes out to 4 pi over 18, which is 2 pi over 9. So this guy is 2 pi over 9. Right? I'm going to keep the 4 pi over 18 and keep adding 3 pi over 18. Brandon, it's flashing in and out. Is it doing that for everyone else? Alright, so this next number is 7 pi over 18. Oh, really? Is everyone else having that same issue, or are you able to see it okay? Are you sitting far away from the router? Oh, when I write? Oh, maybe there's a lag when I write. Sorry, it could be my internet too. My internet here is so bad. I hate Spectrum. Alright, so I'm gonna just write it, and hopefully the what you see afterwards makes sense. Yeah, okay. So 7 pi over 18. I'm gonna add, what was I adding? 3 pi over 18 to that. So when I do 7 pi over 18 plus 3 pi over 18, I get 10 pi over 18, which reduces to 5 pi over 9. So let me write 5 pi over 9 there. And we have all the x-axis labeled properly. And then I know that the amplitude is 5, so it goes from -5 to +5. And this is, what kind of graph is this? This is a cosine graph. So it should start from the very top. All right? Go to the middle, go to the bottom, the middle, and top. And then when you sketch the curve of the cosine, you should get something like that. All right? Any problems? By the way, I'm screen recording this too, so I'll post it around on YouTube right afterwards. So it should be up within like 30 minutes after we're done here. And that one should be smooth without any delay because it's a screen capture. Alright, what else we got here? Okay, on the unit circle, find the value of y for the coordinates of the terminal point of the unit circle, P, which is radical 6 over 7, and y for t equals 5. Okay, so find the y. So what quadrant? Do you know what quadrant we're in when we say t is equal to 5? Does anyone know what quadrant we're in? When t is equal to 5. This is important because if you don't select the correct quadrant, you're going to do the wrong thing. Right? So t equals 5 is like right here. Quadrant 4. Because remember, pi is what? 3.14, right? And 2 pi is what? 6.28 is 2 pi. Does that make sense? So when t is equal to 5, it's talking about a radian measurement. So we're in quadrant 4, right? This is pi over 2. This is 3 pi over 2. And 3 pi over 2 is about 4.7, right? So that's how we know you're in quadrant 4. Okay? All right, so besides that, we already know that in quadrant 4, we don't even like really need to know that, but if you're in the radian mode, you know the y value is your sine, basically, right? Does everyone know that? So let me see here. We could do on the calculator. Where did my square root? Oh, okay. Okay, so the one thing you can do is this, since it's on the unit circle, you could do x squared plus y squared is equal to 1, right? So root 6 over 7 squared plus y squared is equal to 1. So this is equal to 6 over 49. So I'm going to do y squared is equal to 1 minus 6 over 49, which is what, 43, right? 43 over 49, and then square root that, right? So this is radical 43 over 7. So if you do radical 43 over 7, you should get the correct answer. Actually, it doesn't say to, yeah, if this is the exact answer, that's what you would have to write. Otherwise, you could have done it on the calculator as well. All right, moving on. Oops. Huh. Okay, what the heck?